All right, the dreaded friction problem, right? Okay, remember that, and this is like the last question on the assessment, right? We're just going to set the centripetal force equal to friction, right? So the centripetal force, in this case, we want to know the speed of it, so I'm going to use for centripetal force mv squared divided by r, and I'm going to set that equal to mu times m times g, right? And you've got this formula in your packet. You've got this one. You will have to come up with the devilry that is setting them equal to each other, okay? And so if we plug in the numbers here, we've got 1,200 kilograms of car. We don't know how fast it's going, so I'll just write a v squared. The corner is 73 meters, which is a very, very steep corner for a car. Very steep, very sharp. Sharp is the word I'm looking for, right? And 0.34 is our coefficient of friction. 1,200 is here on this side as well, and 9.8 is on this side, right? Okay. Now I'm hoping you see that there's 1,200 on both sides. We needn't worry ourselves with it, right? The mass actually cancels out. You could even cancel it right there. But let's go with that, right? We're solving for v squared, so I start on this side. I'm going to go 0.34 times 9.8, and then I'm going to divide by 73. Oh no, I'm not going to multiply by 73 times 73. And that's going to be v squared, okay? And then I'm going to square root that, raised to the 0.5, 15.6 meters per second. So v is, okay, so let's see. It looks to me like I've answered the speed, but I didn't answer what's the force of friction. So let's find the force of friction. Separate problem, right? Force of friction is mu times m times g, so 0.34. Times 1,200 times 9.8. All right, 0.34 times 1,200 times 9.8. 3998.4. Arrestingly specific, as Bill Bryson would say. All right, that's an 8. There you have it. So, you can leave the mass in there if you want, if you like the mass there. If you don't like calculating big numbers, then you can just cross off the mass. It always cancels from these types of problems.